Every year, thousands of workers are protected by one invisible safety feature you've probably never noticed. It's the reason factory machines don't automatically restart after a power outage. But why? What makes this simple design so important that it's used in factories all around the world? In this video, we're going to uncover the engineering, the science, and the life-saving technology behind it. Imagine you're standing inside a massive factory. Hundreds of machines are running at the same time. Conveyor belts are moving. Robotic arms are assembling products. Forklifts are transporting materials. Everything is working perfectly. Then suddenly, the power goes out. Every machine stops instantly. A few minutes later, electricity is restored. The lights come back on. The computers reboot. But something interesting happens. None of the machines start running again. Why? If the electricity is back, why don't the machines simply continue where they left off? Is it because they're broken? Is it a software problem? Or is there a much more important reason? Today we'll explore the engineering principles, safety systems, and industrial standards that explain why factory machines are intentionally designed not to restart automatically after a power outage. By the end of this video, you'll understand one of the most important safety features in modern manufacturing. What happens during a power outage? Every modern factory depends on electricity. Electric motors drive conveyor belts. Hydraulic pumps provide pressure. Compressors generate compressed air. Robots perform thousands of precise movements every hour. Programmable logic controllers, or PLCs, coordinate every operation. When power disappears, everything stops. Motors lose torque. Production lines freeze. Robots stop wherever they are. Safety systems activate. To someone watching, it may seem like the factory has simply paused. But inside the control system, much more is happening. Controllers detect voltage loss. Safety circuits switch to a safe state. Contactors release. Emergency procedures begin automatically. The entire factory enters a condition engineers call a safe shutdown. Why automatic restart is dangerous. Now imagine a maintenance technician walking toward a machine after the outage. He assumes it's safe because nothing is moving. He opens a protective guard. He reaches inside the machine. He's replacing a worn bearing. Suddenly, the power returns. If the machine restarted automatically, the conveyor could begin moving. A robotic arm could swing into position. A cutting tool could start spinning. Within seconds, someone could be seriously injured or even killed. Unfortunately, accidents like these happened many years ago before modern safety standards became common. Engineers learned an important lesson. A machine should never assume it's safe to restart. Only a human operator can verify that the area is clear. That's why automatic restarting is considered extremely dangerous in most industrial environments. The contactors that save lives? One of the simplest safety devices in electrical engineering is the magnetic contactor. A contactor is basically a heavy-duty electrical switch controlled by an electromagnet. When you press the start button, the contactor energizes. Its contacts close. The motor begins running. A holding circuit keeps the contactor energized. Everything works normally. Now imagine the power fails. The electromagnetic coil immediately loses power. The contacts open instantly. The motor stops. Here's the important part. When electricity returns, the contactor does not close again automatically. Someone must press the start button again. This safety feature is called no voltage release, or under voltage protection. It prevents unexpected machine movement after power restoration. Such a simple design has saved countless lives around the world. How PLC systems make smart decisions. Today's factories rely heavily on PLCs. A PLC is essentially an industrial computer designed to control machines. When power returns, the PLC doesn't immediately resume production. Instead, it begins checking dozens or even hundreds of conditions. Are all emergency stop buttons released? Are all safety doors closed? Are safety light curtains clear? Is air pressure sufficient? Is hydraulic pressure normal? Are motors healthy? Are there any active alarms? Has an operator acknowledged the restart? Only after every safety condition is satisfied will the PLC allow production to continue. In many factories, the restart sequence is gradual. Motors start one at a time. Conveyors accelerate slowly. Robots return to their home positions before beginning work. This controlled startup protects both workers and equipment. Protecting equipment? Worker safety isn't the only reason. Industrial equipment is extremely expensive. Some machines cost hundreds of thousands of dollars. Others cost millions. Imagine every motor in a factory trying to start at exactly the same moment. The electrical demand would be enormous. Large motors draw several times their normal current during startup. If dozens of them started simultaneously, voltage could collapse, circuit breakers might trip, transformers could overload, sensitive electronics could fail. Instead, engineers carefully sequence the startup process. This reduces electrical stress and protects the entire power system. Modern industrial safety systems. Today's factories use multiple layers of protection. Emergency stop buttons instantly remove dangerous motion. Safety relays constantly monitor critical circuits. Safety PLCs verify every safety condition. Interlock switches ensure guards remain closed. Light curtains detect anyone entering hazardous areas. Laser scanners monitor robot work zones. Pressure-sensitive mats detect human presence. Even if power returns unexpectedly, these systems prevent machines from moving until every condition is safe. Safety is never left to chance. International safety standards. Industrial safety isn't just good practice. It's required by international standards. Organizations like OSHA, IEC, ISO, and NFPA establish strict regulations for machine safety. Manufacturers around the world must design equipment that prevents unexpected startup. Failure to follow these standards can result in injuries, lawsuits, equipment damage, and enormous financial losses. Safety is built into every stage of machine design. So, why don't factory machines automatically restart after a power outage? The answer is simple. Because human lives are more valuable than production speed. Automatic restarting could injure workers, damage expensive equipment, destroy products, overload electrical systems. That's why engineers design machines to wait for a trained operator to verify that everything is safe before restarting production. The next time you see a factory remain silent after the power comes back, remember, it's not a malfunction, it's one of the smartest and most important safety features ever developed in industrial engineering. If you enjoyed this video and learned something new, don't forget to like, subscribe, and share it with others who are curious about how factories really work. Thanks for watching, and I'll see you in the next video.